This is the solution to example 2 from notes 2.7. Here we're given some discrete points, and we are going to find the inverse for this function. So here I'm going to make a mapping diagram to review what we did at the beginning of this unit. So a mapping diagram, I'm going to put my inputs in this oval, and my inputs or my domain are these particular values. So 0, 1, 2, and 3, those are the inputs, and they're mapped to the outputs. So I'm going to make an oval over here. I'm going to put the set of outputs, which are going to be the values 1, 3, 6, and 9. I'll put those in 1, 3, 6, and 9. And then I'm going to map the inputs to the outputs. So 0 goes to 1, 1, 2 goes to 6, and 3 goes to 9. And that's our mapping diagram for this function. What's the domain? When we have discrete points, the domain is just the set of those inputs. So it's the values 0, 1, 2, and 3. And the range is going to be the set of outputs. So it's a discrete set. I'm going to use set notation. So it's the values 1, 3, 6, and 9. The inverse, so what an inverse function does, it undoes the original function. So it's going to invert all the arrows, and it's going to map the range onto the domain. So if we're going to map the inverse, I can do that now. So I'm going to make a new mapping diagram. So I'm going to map the range, so 1, 3, 6, 9, onto the domain. 0, 1, 2, 3, and then I'll show that 1 maps to 0, 3 maps to 1, 6 maps to 2, and 9 maps to 3. So the idea that an inverse switches domain and range is going to be important.